Good morning, students. So today the topic of discussion is content delivery. So we are commencing unit 3 today. Do you have any doubts in unit 1 and unit 2? All right. So content delivery network. So what happens is there is some content available on the internet, and also you can have content in your cloud as well. So how to manage and speed up the access and retrieval of content is all about the main topic in this chapter. Consider a cloud. Here we have a cloud and we have resources, servers on the cloud. Then a user outside the cloud try to submit an application for execution. What is this known as? This is compute task. Compute task means you are giving an application for execution to a server. Server executes it and returns the result back to the user. User gets the result. So this is like compute. Students, please mute your mic, all of you. And another scenario we studied in which we have databases. In that case, a user can create data, store data, and can retrieve data. This is data related task, data related computing. This is compute related computing. Essentially, content delivery network deals with content management. What is content? Content, there are different types of contents. Like you can have documents, you can have articles, you can have even a complete application as your content. Then what uh, the cloud has to do with respect to the content? Then cloud will have content servers, dedicated servers for content delivery. All right, these are servers and they are mainly placed everywhere, throughout the world, so that if I access a content, I get the content from my nearby location. The whole idea is to speed up the task, to improve the performance, to reduce the lags, to reduce the issues that may arise if content is not delivered on time. This user stores the content and retrieves the content. Alright, this is the gist of this chapter. So cloud computing are not only made for network centric computing but also for network centric content management. Network centric computing implies that over the network you perform various tasks like execution of the program, uh, creation of database, retrieval of database, and several other operations over the network. This one is content centric network centric content management, is related to the instant delivery of content via network to the consumer. In this example, this is network. Here user is connected to cloud through network. This like network boundary. It's a cloud uh, which is having a network boundary. So over the network user is connecting to the cloud. So over the network, if user is able to retrieve the content instantly, then to perform that, there is a concept of dedicated network for faster content delivery. And content generators like cloud service providers can make use of these networks for efficiently delivering their content to millions of consumers across the globe. Efficiently deliver the content. Content delivery in the cloud. The content, it can be data ranging from text to audio, image, video, and anything. Anything can be your content. Delivering this content is a critical issue. Why it is a critical issue? If you store a video of your birthday, for instance, on the cloud, and you have stored the video, birthday video. Now your friend has arrived to see you, and your friend asks, show me your birthday video. And if it takes 1 hour or 2 hours or 10 minutes or half an hour, more time, in other words, then the enthusiasm, will not be there, and there won't be any interest also, right? So it's very essential to have quickly delivery of the content. That content should be delivered quickly to the user. So that is what is this. And then content can be created by content creators. uh, have you heard about medium blogs, or even on YouTube you can see there are so many uh, video bloggers, vlogs, no, as they are known as. If you are creating a video and you upload on YouTube, that is a content that you have created and you have uploaded, and then later another user would like to view that video or download that video. For that, again, it should be done effectively on time. So here the concept is that content can be created by you, by someone else, by anyone in the world, and the content can be available in the cloud from your end, from some other person's end, or from anyone for that matter. You take an example of TikTok videos. Now, obviously, they are not there, but when they were there, anybody used to contribute in that, and anyone can use to view that. And it was so fast that to view, if it takes more time, there won't be any interest in that. Okay, students. So, eventually, fast web content delivery is essential for producing high performance computing in cloud for better quality of service. This is the whole idea about this chapter. What is the problem? The problem is delivering content. Why it is problematic? Due to the distance between the source of the content and the location of the content consumer. If someone, for instance, a professor at Stanford has developed a content and has posted it in his area, server located in his area, and we here from Hyderabad would like to view that. So the distance is more, and due to the distance, there might be problems due to centralized server bottleneck or contention problem, network traffic problem. There might be the many no problems. So the source of the content and the location, and the location of the content so uh, content consumer. We are content consumer, and content is located somewhere else, and the source is uh, far apart from our place. So that is the problem. What is the solution? Solution is designing a new model for content delivery to overcome the above mentioned problem. All right. So what is the new design? The new design is to have a network of cached servers. There are servers that cache the content for faster and efficient delivery, is known as content delivery network. You have dedicated servers. Suppose on this server I am uploading my videos. All right. and I am here. My location is here at Hyderabad. Somewhere else in US, someone wants to view that. So what can be done? There is a user here. A content delivery network is created. What is this content delivery network? It is a network of servers that caches the content. So here in US we place one server that cache the same content. Suppose content C1. Here also you will find C1. Somewhere else in Australia there is another server. Here also you have C1. You are caching, placing a copy at various servers, at various locations for faster and efficient delivery of content. So this user need not contact a server 1. This user can get no need of this. User can get the content from server 2, which is part of content delivery network of servers. And this user can get from server 3. All right. Content delivery network. What is it? It is a network of servers. Uh, and here servers are distributed. If you look at previous example, servers are distributed. Distributed in the sense spread across geographical areas. One server is here in India, another in US, another in Australia, another you can put in Africa. So servers are distributed. A content delivery network is a network of distributed servers. What is the speciality of the servers, distributed servers in CDN? That they contain replicas, all right, in the form of a cache. The content that is frequently used, that is used at multiple locations, is kept on multiple servers which are distributed, all right. And you can here consider the geographic location. Based on the geographic location of the request, the location of the content server is determined. Here there is a server in US, and there is, suppose, a user from Canada is willing to access C1. What is the geographic location of this user? Canada. Which is the nearest server to this Canada? It is the server located at US, not the one located at Australia or India. So what happens? The request will be redirected to this US server based on the geographic location. The actual or original source of any content is known as content source or origin server. In our previous example, origin server is S1 because that is the source of the content that has been generated first hand. And the additional content servers placed at different geographical locations are known as edge servers. All right. What I said here in our previous example, this is known as origin server here. Content server or origin server, because at this server the content was generated first initially. All right. And S2 and S3 are edge servers. There is another a way of improving the performance further. What is that? This Canadian user is trying to access US server. Instead of that, you can have another server here and you can place this C1 here. So this Canadian server need not go to this US server, can access from here. This is C1. What is this now? That is edge cache server. Edge cache server means it is a content server that is storing the cache copy, a replicated copy of the content. So here there are three types of servers: content source or origin server, edge server, and edge cache server. And then any request is automatically routed to the closest server. And here the closeness is defined by time, not miles. All right. The how much time it takes. Sometimes, going from this point A to point B, which is just 1 kilometer, will take 1 hour, in which you can travel from point A to point B, which is 10 kilometers in 1 hour. This is possible. If there is a huge traffic here, then what happens? You are spending whole hour waiting only to go from point X to Y. That is just 1 kilometer away. Look at here, when it is 10 kilometer away and you are taking equal amount of time, perhaps because there is no traffic here. So it's not always the the distance that measures how much time performance. It's not always the distance that gives the performance. Sometimes uh, a longer distance gives better performance than shorter ones. All right, next. Next important point is here CDN Content Delivery Network places the copies of recently used content and created content in edge servers that are closer to the consumers. This network is also called as edge network. Why it is also called as edge network? Because it encompasses edge servers that hold the data from the origin server. and the objective is to have less latency and maximize the bandwidth. That is the objective. Content delivery network operator can have thousands of nodes spread across the world. Each such node is made up of large number of servers. Alright, like you have internet service providers, cloud service providers. You probably can have content service providers, and they will have uh, you know large network having many servers in them. And the location where you are placing the nodes, what are these nodes? Nodes are nothing but the servers. That is known as point of presence. So if I ask you, what is your point of presence? If you are a content provider, then you can say my point of presence is here in Malaysia, this Indonesia, or in Asia, and then in Europe somewhere, Italy, and some places, and in North America, some places like that. Digital content is categorized into two types when delivering of the content is concerned. With respect to content delivery, there are two types of content. First one is static content, second one is dynamic content. Static content generally do not change. That includes HTML pages, images, audio, video files. Static content is supported using traditional caching techniques because changes are rarely done. And next one is live media. What is live media? Live media is the content that is generated in real time. Now, whatever I am recording here, that is live media. And if suppose I use YouTube for streaming, I can stream this class, right? If I stream this class, then it becomes live streaming of this cloud computing class. And this can live streaming happen for many things. For in sports, you can live stream the data. Any event, Olympics, or even a presidential address, prime minister address. There's so many things which you can put on live. This content is quite different from the static content. Why it is different? Static content, in case you have 10 HTML pages or 10 images, this 10 images is your content, and these 10 images are your passport photos, and you want to have them as your content. Then these may not change unless and until you take another passport photo and add to this. This will rarely change. In 2-3 years we take photos, passport photos. So this is static. Live media, suppose the event which is occurring generates a lot of data online in real time, and providing that sort of content is different, right? And providing this content is different, and live stream content is different. Which one is more challenging? Live stream is more challenging. Why it is challenging? You see, sometimes due to many uh, uh, issues of network or power supply or even app, even our classes get disturbed. And if there is a delay, then I after I speak, after 2-3 seconds you will hear it. Apparently live media and live streaming is very challenging and difficult content delivery. And what is policy decision? Policy decision means how to create CDN, means content delivery network. What are the design decisions? Where to place edge server? Where, how much data to be replicated? And which data should be cached? And how it should be updated? And if there are two servers nearby user, which request should be routed to which server? Okay, request routing policy. These are all policies that determine the design of CDN system. And then perhaps heuristics helps in this solving this problem. If there are several users, we can say that Bangalore is IT hub in India. In Hyderabad, high tech city is the IT hub. Like that we say. So, what does it implies? It implies that you can have one server there because all IT companies have their offices located in that area. So there will be many requests generated from that area. Such type of things are known as heuristics, and these heuristics can assist in coming up with the solutions to these decisions. And there are two policies for content management. Here we have content management, how to manage the content. This is about placement of the server, some heuristics you can use. How about content management? Content management, you can replicate the whole entire site, full site replication or partial site replication. If I have my website, if that website is visited by many users, consider, then I can replicate my website on multiple edge servers. Or if many users are accessing my research details, then no need to replicate entire website. I can only have my research details placed on multiple edge servers. So full site, everything you have to replicate. Partial site, the most frequently accessed and used content will be placed. And caching technique, how to update the cache. If I place my website on multiple edge servers, and suppose a new paper has been published by me in this month, and those replicas do not contain that newly published paper, automatically it won't get updated, right? We have to do it. How are we going to do it? It can be on demand updates, periodic updates. Periodically, every 6 months I update my website. Or if some user uh, ask me, mail me and ask me, do you have any updated publications, then I post. So on demand or periodic. And through request routing, the user requests are directed to the optimally closest edge server. How this is done? This is done by having the information about how much time it is taking from Hyderabad. If request is arriving, then consider that there are two servers, one is in Bangalore, another is in Chennai. So to which server this request should be forwarded? How can it be determined? uh, by by maintaining a record wherein uh, how much time it is taking for the request to reach the server and response to arrive the user. If you maintain that information, then you can know that this this one is more optimal for this place. And always it is not about the distance in miles or kilometers. We can't say that if the server is 100 kilometers away from Hyderabad, uh, and another server 1000 kilometers away from Hyderabad, we can't predict the time, in how much time 100 kilometer server will give response. If suppose server at 100 kilometers is having heavy load, then it can't give a response on time. So depends on load, depends on various other factors. It is decided which is the closest edge server. Okay, so this one, push and pull. Okay, there is another top concept here. We studied about load balancer. This load balancer can be extended to have information about this content, and it is known as application delivery controller, which balance the load on content servers. Push and pull. What is push and pull? The content, if you have a SIM card from Airtel, for instance, consider if Airtel has released a new plan 650. Okay, this 650 will give perhaps 2.5 GB of data for 84 days. Suppose this is the plan. Now this can be reached to the users in two ways. What are the two ways? The Airtel itself send this information to all the users. A new plan has been introduced. It is very beneficial, and it gives high speed 2.5 GB data and free incoming outgoing calls and all. that that message has been sent to all its users. Another way is what? Airtel introduces a new scheme or plan, but do not propagate this message. Rather, keep it with itself, and whenever this user 1 would like to do recharge, user 1 will ask, do you have any new plans? Then Airtel will send message, yes, I have this new plan apart from all the old plans. So that is the concept of push and pull. This content is being pushed to the user, or user is requesting and getting it. So here we have origin server and content edge servers. Here you consider this Airtel to be origin server, and these three users, user 1, user 2, user 3, to be edge servers. the original copy is at origin server. That original copy can be updated. When the copy is updated, how edge servers get to know about the updates? Uh, Either the origin server push that information to all the edge servers, or edge server look at here in pull mechanism, latest version of the content is not transferred to edge server automatically. Pull means this edge server have to pull the data, means request and ask and get. Okay, that is pull mechanism. Push mechanism is okay, consider this to be origin server. This is edge server 1, edge server 2, edge server 3. Okay, what is the problem in pull mechanism? Every time user has to ask. Instead of that, in push mechanism, content is automatically distributed or pushed to the related edge server. This is push mechanism. The model of CDN, here you see, this is content origin, this is the publisher of the content, this is content delivery network, and these are subscribers. You content request, content delivery. Then this is transfer of published content from content origin to the content delivery network, which has edge servers, and publisher authorizes the edge servers to share the copy with the subscribers. Okay, if you consider this in this scenario, you can see that uh, the content has publisher and subscriber. Publisher is the creator, subscriber is the consumer, and in between you have origin server where publisher has published initially, and then you have content delivery network to speed up the task for effective delivery uh, to the subscribers across the uh, you know various geographical locations. How the CDN service operates? CDN is also a service, and it is offered by some application service providers on the internet. Content providers such as e-commerce vendors or media companies may develop their own CDN infrastructure. You can develop your own CDN infrastructure, or you can utilize this service by some application service provider. CDN minimizes latency, optimizes delivery speed, maximizes available bandwidth for each client. Evolution of CDN. How CDN has evolved? CDN has evolved. Yes. CDN has evolved from having a single server with different problems to multiple edge servers solving several problems. What is the advantage of CDN? Okay, I will mark some important points here also.
Ma'am, not audible, ma'am.
Oh my god. Means from when I was not audible? Hello, students?
The past 2 3 minutes.
Oh god. Oh my god. I don't know what the concepts this evolution did you listen? How CDN service operates? Did you listen? Students, please tell me what was the last topic. Yes, just now who spoke to me? Rakesh?
Ma'am, Sagar.
Rakesh? Sagar?
Sagar, ma'am. Yes,
Sagar, very good, Sagar. You should have informed me. Okay, tell me, Sagar, which concept you heard last? This one?
yes, ma'am.
No,
Yes, ma'am.
this one
Listen.
clear. Listened. This how CDN service operates. Listened.
Oh, ma'am.
No. Okay, then from here I
Oh,
will tell. So how CDN service operates? Uh, CDN service is provided by application service providers (ASPs) on the internet. If companies would like to have their own CDN, then they can go for some private CDN infrastructure and they can have their own network. That is how CDN operates. You can use uh, services offered by ASPs, application service providers on the internet, or private content. Then, okay, then evolution. How CDN came into existence and how it has evolved. Initially, in the beginning, CDN emerged towards the end of the last century to have multiple copies of websites. As internet was growing, several users were accessing websites, and if you have your website, If you take an example of Nizam College website, Nizam College website is accessed by the students and the potential students and the parents and several other stakeholders from across the globe. It's not just from Hyderabad we access. From many countries, this website is being accessed. If it is only stored on one server, then it becomes a bottleneck. How it becomes a bottleneck? Sometimes users from uh, UK's, for instance, trying to access this, they are far apart. There may be some network problem, latency problem, bandwidth problem, uh, this server down problem, some problem may happen. So instead of having this Nizam College website on only on one server, uh, initially at that time they started placing these websites on multiple servers. Here also you will find Nizam College website, here also you will find Nizam College website. But how this trend has picked up due to the demand of newspapers in US. Newspapers like New York Times, they wanted to deliver graphics via cache. You can have cache. Some of the logos and some of the graphics you can place in cache. Then you need not send over the network again and again. What you can do, you can just use what is available here in cache. Uh, Apparently at that time that was the primary use, and Limelight and Akamai, these are the two companies that led the advancements in this area. And at that time it was not called as CDN, content delivery network, it was called as web acceleration. Why it was called as web acceleration? Because it has speed up the process of accessing the websites. And later, uh, initially it was only the static content. Later dynamic content was also being added to the websites, and then using the push technology, servers were pushing the updates to the cache. And now in the current century, there is enormous storage capacity in quite less cost. Network bandwidth is also available on phone only. We are getting so fast network. Then uh, video and audio became quite prevalent, and at that time the amount of data CDNs to the amount of data to handle were increased, and there was a need to have content delivery networks so that they quickly video and audio and other images and several different types of content could be delivered to the users. All right, that is the uh, evolution, how it has evolved. And later there was a demand for live video streaming, and that is the second generation of CDN, live video streaming. You can now have live TV, video on demand, TV on demand, videos streaming, so many things. So all that is now the current generation of CDN, which is the second generation. What are the advantages of CDN? Accommodating heavy traffic. Obviously, if there is one single route, then traffic will be more here. If you have multiple ways to reach to the same place, then you can divide the traffic. Support for more simultaneous user. Again, this is also, if there is only one server and number of users, then what happens? Again, all problems arises. Uh, uh, congestion problem, network traffic problem. If you have multiple servers, if you have multiple servers here, here, then you can have more simultaneous users. Few users will connect to this, few users will connect to this, few other users will connect to this main server. Then less load on servers. If you have 10 servers having single website, and then if you have 100 users, so 10 every 10 user will get one server. So, then it reduces the load on the server. If there is only single server and 100 users, all 100 users will request the single server, and that will increase the load on the server. Faster content delivery, because servers are geographically closer to the request content consumer or content request, then it delivers the content faster because it is nearby. Lower cost of delivery, cost is less because the uh, travel time is less, and then it decreases the load on network backbones, and overall it reduces the cost of delivery. Controlling asset delivery, this CDN network load and asset being delivered can be monitored by CDN. Content delivery network can monitor the network load of each server, and also what are the assets, what are the important elements, that is also can be monitored by this CDN. So CDN can control the access, and suppose if something sensitive is there, and if user is not having the authorization to access, then CDN will stop the user from accessing that. CDN can have all the privileges. CDN can monitor. Facilitates scalability. If there are 10 servers, if there are 100 users, means user will have each server will have 10 users, for instance, on average. If more 100 servers are added, you can add more 10 servers, so you can scale up the system in a easy manner. And better security, security CDN, all the content files are replicated in multiple content servers, and if suppose uh, any one copy is damaged or destroyed or deleted, then you can get the same data from another additional server, and thus you are securing the data from loss by natural that loss can occur from natural disasters like floods or fire. What are the disadvantages of CDN? New points of failure, additional. You look at disadvantages are very few. New failure in the sense that if there is a chain, and if any one content Cdn service provider fails, then what happens? The users who are consumers or subscribers who would like to have the content will not get the content if the CDN fails, or if any uh, important connection that connect the entire CDN fails. Okay, there is a chain sort of thing, that if there is one server failing in that chain, it would become difficult to further traverse. Additional content management task, uh, all the advantages comes because of separate CDN. And to manage CDN, we have to have extra tasks like having edge servers and maintaining the updates, and having the proper edge server in proper geographical location. Okay. CDN service providers. Who are the CDN service providers? Uh, the important ones are HMI and CD networks, CloudFront, Cloudflare, Cachefly, Max CDN, Azure CDN. These are the few instances of the CDN service. And the choice of CDN vendor or service depends on factors like volume of business, which one to choose, whether to go for Azure or whether to go for CloudFront, depends on the how large is your business, what are the performance goals, and what are the locations of your customers. Okay. Based on these parameters, you can choose any of the CDN provider. HMI Technologies is a company at Cambridge, United States, and they are the leading cloud computing services and content delivery networks provider. This HMI not only provides CDN, HMI also provides cloud computing and CDN. And Limelight is another Amazon's CloudFront, Azure Content Delivery Network, CD networks. Please go through. If you find any difficulty, you can ask me tomorrow. That is just the information about the content delivery providers. And content delivery network is developed based upon the principle of uh, this delivery management. The additional content servers in CDN placed at different geographical locations are known as edge servers. Partial site replication is followed while web pages include um, static and dynamic content. Partial site replication is followed in CDN while web pages include static or dynamic content. User requested content is always delivered to user from the origin server. False. Content consumer remain unaware about the use of the CDN service by content providers. Uh, I think it's true. Then the placement of edge servers mainly depends on location of content providers, geographic location of user, availability of space, policy of CDN operator. So it is placement of edge servers mainly depends on the policy. They make some policy decision based on a content provider can use the services of more than one CDN operator to deliver its content. Yes, yes, possible in some cases or depends on the content type. A content provider can use the services of more than one CDN operator to deliver its content. Yes, it depends which of the which of the following cloud service provider has its own CDN? All have their own. Amazon has, Microsoft has, Google has. The use of content delivery network is required for reducing network traffic, instantaneous delivery of content server, all of this. Content is automatically distributed to edge server whenever added to origin server using automatically means push. Automatically is push technology. Okay, fine. So tomorrow we'll look at this chapter. Any doubts in this chapter? Okay, students, then See you tomorrow.